Yeah, good evening everyone. Good evening. Check audio video is okay or not. Yeah, let's start this. So if at all audio video is okay, let's see this. Let's see this one. Just give some time. I think some fault is there. Just wait 1 minute, just wait. Yeah, just verify now. Now verify. Yeah, now verify. Verify audio video okay or not. Yeah, I hope it's fine. So let's see the first problem of today's class. See the first problem of today's class. Let M be the encoding of a Turing machine as a string over sigma is equal to 0, 1. Let L is equal to M is a Turing machine that accepts a string of length 2014. Then L is. It is a given problem. Can we check once? right? So what is the answer for this? Let M be the encoding of a machine, Turing machine, as a string over sigma is equal to 0 comma 1. Let L is equal to M is a Turing machine that accepts string of length 2014. So remember this one, right? So there is a Turing machine, to this Turing machine. If you give string of length 2014, if you give string of length 2014, right, it will say yes, means it will go to halt final state. If you give other than 2014, if you give less than 2014, if you give greater than 2014, right, so it will say because of it is a no invalid, it may go to halt to non final, it may go to hang also, if you give if you give the invalid thing, right, it will, because of it is a invalid string, it may go to halt non final, it may go to hang also. What is the meaning? 2014, if you give, if 2014 length, if you give, this Turing machine will go to halt final and accepted. Other than that, if you give, it will go to halt non final or hang. So remember, for valid thing logic is there. For valid thing logic is there, invalid thing no logic. So valid thing logic is there. Invalid no logic. Invalid no logic means undecidable, but because of valid one having logic, so recursive enumerable. Answer is B. Undecidable but recursively enumerable. That accept string of length 2014. If you give string of length 2014, it will accept. Other than that, because of invalid, right, it may go to halt non final, it may hang. So answer is going to be option B. Right? Please careful. Let's go to next problem. Can you see this? Can you see this problem? Let L is equal to Tm, where Tm does not halt on W within k steps, then L is. Let L is equal to Tm, where Tm does not halt on W within k steps. Turing machine is given, right? And he is saying Turing machine is given, string W also given, and he is saying that, right, on string W this Turing machine doesn't halt within k steps. Doesn't halt within k steps. It is a very tricky problem. Let L is equal to Tm, where Tm doesn't halt. On string W within k steps. So what is the answer for this? It is a really tricky problem. Can you check what will be the answer for this? Yeah, can anyone help? What will be the answer for this? Can anyone help? What will be the answer for this? So what he is saying is, it is right, L is equal to language of Turing machine, where Turing machine does not halt on string W within k steps. I think what you do is, right, he is not asking all. String W within k steps doesn't halt. Take the string W, right, do k steps, right, within k steps it is halting, say, right, so within k steps it is halting, right, so it is a fail. Suppose assume that within k steps it is not halting, right, say yes. Within k steps it is halting, say no. Within k right, after k steps also still not halting, then say yes. I think after k steps I can give the answer. Within k steps it is halting, no. After k steps, right, k steps are over, still not halt, say yes. So I think within k steps I can give the answer. Within k step you can give the answer. Within k steps you can give the answer. So it is going to be a decidable. It is going to be a decidable. K steps are more than enough. Just to do k steps. Within k steps you can decide the answer. Within k steps you can decide the answer. Just to do k steps. Before k steps only halt, no. After k steps are over, still not halt, means yes. So within k steps you can decide. Within k steps you can decide. So answer is decidable language. Answer is decidable language. And let me see this also. Those people who are watching, one wonderful offer is going on in Unacademy, 53% off. Wonderful offer is going on, 53% off. If you take subscription today, before 12 o'clock, if you take subscription today before 12 o'clock, 53% off going on. If you are really serious about GATE examination, my sincere suggestion is you can take the subscription today. Use the referral code ReddySir. Use the referral code ReddySir. You will get the 53% off. Next one, right? If you want to go for EMI, you can go. No cost EMI, 0% interest EMI, you can go. Within 2 hours they will approve. Within 2 hours they will approve. And one more, printed notes also available. Printed notes available, you can buy. 20% off. Use the referral code ReddySir. Next one, you can go for plus also, you can go for iconic also. You can go for plus also, you can go for iconic also, whichever you feel. And one more thing is, see this one, algorithm data structure going on. Algo and DS is going on. Algo and DS is going on, right? 7 a.m. to 10 a.m. 7 a.m. to 10 a.m. Algo DS is going on. I am teaching algorithm, data structure, compiler design, TOC, computer network, discrete mathematics. I am teaching all these 6 subjects, right? Approximately 70 marks will come, approximately 70. Currently Algo DS is going on. It will be useful for campus placements. It will be useful for, right, PSU exams. It is useful for GATE exam. It is useful for MNC exams, right? Please be careful. So join this batch. Algo DS is going on 7 a.m. to 10 a.m. Use referral code ReddySir. Use referral code ReddySir. Next one. So you can go for EMI 24 months plus course per month 1990, 18 months 2021, 12 months 2618. So like that. Per month this much you have to pay. Use the referral code ReddySir. You can go for iconic also. 24 months per month this much, 18 months per month this much, 12 months per month this much, 9 months per month this much, 6 months per month this much. right? These are the best thing of today's offer is, right, 53% off you can utilize. 53% off you can utilize it. Now go to the next problem. Can you say what the answer of this problem? Check. Let L is equal to T of M, where Tm halts on W within k steps. Tm halts on W within k steps. Check once what will be the answer for this. Verify what the answer for this problem. Let L is equal to Tm halts on W within k steps. Then L is, let L is equal to Tm halts on W within k steps. Then L is, so what you do is, right, Tm halts on W within k steps. Tm halts on W within k steps, right? So what you do is, right, this is the Turing machine, if you give W according to this problem, give W only, is talking about only W. Tm halts on W within k steps, give W, right? So just to do k steps, after k steps are over, Tm halts on W within k steps. Within k steps, if it is halt, yes. Suppose k steps are over, still not halt, then no need to go further. Just to do k steps, if you are lucky, within k steps it will halt. Then say yes. If after k steps over, still not halt, no need to go further, say no. Just within k steps you can finish this problem. Previous problem, this problem. What is the previous problem? Doesn't halt on W within k step. Here also do k steps, but after k steps are over, doesn't halt, then say yes. Before k steps only it is halted, then say no. So here also k steps are enough to solve the problem. In both the cases k steps enough. In both the cases k steps are enough. This problem, that problem similar. Within k steps you can decide. Both the things are same. Yeah, both the things are same. Right? Please verify if you have doubt. This problem, previous problem, wonderful problems. They are wonderful. This problem, previous problem, excellent problems. Right, let's go to next. Can you see this? Let L is equal to T of M, where L of Tm is less than or equal to 2. Let L is equal to T of M, where L of Tm is less than or equal to 2. Means this Turing machine will accept, right, less than or equal to 2. What is the meaning? It will accept either 2 strings less than or equal to 2 strings. It will accept 2 strings less than or equal to 2 strings. That means indirectly it is saying that it will accept maximum 2 strings only. So what you do is, you have to verify every string. It will accept maximum 2 strings only. Suppose assume that first 2 strings are accepted, you cannot stop. First 2 strings are accepted, you cannot stop, because it is accepting only maximum 2 length. Sorry, maximum 2 strings only. This language accepting maximum 2 strings only, means either 0 strings or 1 string or 2 string. So if anywhere accepting 2 strings, you cannot stop, because you have to make sure remaining thing will reject also. Remaining things will reject also. Only 2 things are accepted, you cannot stop it, right? You have to continue further. So according to this language, S case is maximum 2 things should accept, right? Remaining things all should reject. 0 accepted, no problem. 1 accepted, no problem. 2 accepted, no problem. More than 2 not accepted. So according to this problem, S case is going to be less than or equal to 2 should be accepted, remaining should be rejected also. But remaining should be rejected also. Their problem will come. Their problem remaining, right, should be rejected also. When you are checking, you will go to infinite loop. So what I want to say, here S itself, no logic. What is the S here? Less than or equal to, the number of strings in the language L is less than or equal to 2. Means what the meaning? Maximum 2 people should accept. Here S case is maximum 2 people should accept, remaining all should reject. Remaining all should reject. This is the S case. So this one somehow you manage, but this one also you have to take care, right? When you say reject, you may go to infinite loop also. Here infinite loop is possible. Infinite loop possible. That is the reason. S case don't have logic here. S case don't have logic here. So what is the answer? Undecidable, but not even partially decidable. C is the answer. Undecidable, but not even partially decidable, right? Undecidable but not partially decidable, because S itself don't have logic. Those people who are watching, if you have any doubt, you can ask me. Those people who are watching, if you have any doubt, you can ask me. Check one small doubt also there. S itself, here what is the S, here what is the L here? Maximum 2 strings only should accept, means, right, maximum 2 should accept, remaining should reject also. So S contain here big story, right? Accepting 2 people maximum, remaining people should reject. Remaining people should reject. But when you are checking remaining people reject, there is a chance of infinite loop also. There is a chance of infinite loop also. So S don't have logic. Yes, don't have logic. So careful. Those people who are watching, if any doubt is there, let me know. Sir, this is my doubt. You ask me, I will help. Rupa, you can ask me. Any doubt is there, let me know. Right, L is equal to Tm, where the language of Tm contain maximum 2 strings. Maximum, what is the meaning? 3 not allowed, 4 not allowed, 5 not allowed. Right, let's go to next. Can you see this? Let L is equal to Tm, where Tm reaches state Q within 200 moves. Let L is equal to Tm, where Tm reaches state Q within 200 moves. Let L is equal to Tm, where Tm reaches state Q within 200 moves. So start the automata from starting state. Right? Let L is equal to Tm, where Tm reaches state Q within 200 moves. So what you do is, take every string, run on the Turing machine from starting state. Take every string, Start, right, run the Turing machine from starting state. Continue until 200 moves. Until 200 moves. So 200 or less than 200, at anywhere if you enter into state Q, stop that string. Take the string, right, take the string S1, start from starting state, continue until maximum 200 moves. Within 200 moves, if you reach at anywhere state Q, stop it. Then take the second string, do like that. Take the third string, do like that. I think every string you can do like this. So I think after 200, right, continue 200 moves, right, at the 200 move you can decide the story. Suppose 200 moves are over, still Q is not came, means it is invalid. 200 moves are over, still you are unable to reach Q, invalid. So within 200 I can decide. Within 200 I can decide. Within 200 I can decide. It is a decidable language. It is a decidable language. Within 200 moves we can decide. Right, check this also. Let L is equal to T of M. Let L is equal to Tm, where Tm accepts at least 3 strings. Let L is equal to T of M. L is equal to Tm, where Tm accepts at least 3 strings. At least 3. Means minimum 3, right? Minimum 3 strings. So you will try the, right? So one thing, so minimum at least 3 strings should be accepted. So take the first string and verify. Take the second string and verify. Suppose that first string is, right, first string is accepted. first string is accepted, right? First string is accepted, then go to the second also accepted, then go to third. So at least, right, 3 strings you have to check. While checking that one, there may be chance that you will go to infinite loop. There may be chance that you will go to infinite loop. So if you are lucky, first 3 itself you will get. If you are unlucky, you have to keep on go. So answer is going to be, right, undecidable but partially decidable. If you are lucky, you will get, otherwise you don't get it. Undecidable but partially decidable. So can you help me? What about this? Let L is equal to Tm, where Tm has at least 3 states. Right? Let L is equal to Tm, where Tm has at least 3 states. At least 3 states. So what will be the answer for this? Let L is equal to Tm, where Tm has at least 3 states. So because of he is asking states, if you see this problem, because of he is asking states, there is nothing to do, because of he is asking states, there is nothing to do with the, right, with the machine inside. Just see, because of automate, Turing machine is given means states also given. Turing machine given means states also given, right? So whenever Turing machine is given, go to number of states and count the number of states. If the number of states are, right, minimum 3, accept, otherwise reject. So number of states and the inside the machine, nothing to do, so decidable. It is the decidable. Turing machine has at least 3 states. Turing machine is having at least 3 states, So just check in the automata how many states are there, because automata given means states also given. Check how many states are there. States are given, just count one by one. 3 are there, stop and accept. So decidable. Now can you help me? Let L is equal to Tm. Tm accepts recursive. Turing machine accepts recursive. Turing machine accepts recursive. It is tricky. Turing machine accepts recursive. They are not asking you, right? They are not asking you. So see this one, what is saying? L is equal to Tm, Tm accepts recursive. Tm accepts recursive, of course, decidable. Turing machine accepts recursive languages, yes. Turing machine normally accept REL, it will accept recursive, yes. It will accept PDA, yes. Right? Turing machine accepts PDA, yes. Turing machine accepts regular, yes. Turing machine accepts REL. PDA accepts regular, yes. Turing machine accepts REL, of course. Can you help me now? Turing machine accepts non-empty language. Turing machine accepts non-empty language. Everyone know Turing machine accepts empty language or non-empty language. Undecidable. It is I think closure properties. Turing machine will accept empty language or non-empty language. Undecidable. It is undecidable. Next one, Turing machine accepts A star. Turing machine accepts A star. Given Turing machine accepts A star. Given Turing machine accepts A star. So you have to take care. Given Turing machine accepts A star, verify A star is accepting or not. If you want to know it is accepting A star or not, if you want to know, other than A star should reject also. Turing machine accepts in A star or not, other than A star only it should accept. Other than A star should reject also. So A star should accept. Other things should reject also. Other should reject also. This is the part of the yes. Turing machine accepts A star means you have to verify A star accepting or not, other things rejecting or not. So I think other things rejecting, I think you may go to infinite loop. So answer is going to be undecidable. But not partially. But not partially. Next one. Let L is equal to Tm. Tm accepts finite language. See, Tm accepts finite language. Same thing like previous one. Finite language, let us assume that Tm, right? Tm accepting only A, B, C, D. Only A, B, A, A. Tm accepting only A, 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 B. What is the answer? A, B accepting, A, A accepting. Other things should reject also. Other things should reject also because it should accept only A, B, A, A. Other things should reject. When you checking other, you may go to infinite loop. Undecidable but not. Right? But not. Right? Undecidable but not. Even partially decidable. C is the answer. Next one. L is equal to Tm, where Tm accepts only string W. Only problem is coming. Only string W problem is coming. What is the meaning? You should accept W, other should reject also. When you are trying other, problem will come. So I think all the three problems if you see, looks like similar. Different ways of asking. L is equal to Tm. Tm accepts some string. Tm accepts some string. Tm accepts some string. So some string you are trying one by one. If you are lucky, you will get. Otherwise, you don't get. So I think it is going to be some string. B is the answer. If you are lucky, you will get it. Tm accepting some string. If you are lucky, right, you will get it. Otherwise, you will go to infinite loop. So answer is going to be undecidable but partially decidable. Some string. Tm accepts string W. Yeah, if you are lucky, it will accept, right, other things, right, otherwise it will reject. So it's everyone know halting problem of a, sorry, what is the meaning of this one? Membership problem of your Turing machine is undecidable. This is called membership problem, right? Previous one is what? Previous one, accept, that is also, right, same thing using Rice theorem. Undecidable but partially decidable. Tm accepts epsilon, same membership problem. Undecidable but partially decidable. Tm halts on epsilon, same. It is a halting problem of a Turing machine. Undecidable but partially decidable. Next one, HTM. It is not a Tm, HTM. HTM accepts epsilon, right? I think you can say decidable. HTM always halts. HTM always halts. So please careful. See, all the problems I explained, anywhere if you find out any doubt, please let me know. Anywhere you find out any doubt, sir, I don't accept this. This is the, right, this, I am thinking like this. You said like this. If you have any problem, please let me know. If you have any problem, please let me know. Almost like these are, today I explained from this problem. Today I explained from this problem. For this problem answer is, what is saying? This Turing machine accepts string of length 2014. If you lucky 2004, right? 2014 accept, okay, but what about other? Others will be rejected. So I think 2014 only logic, others don't have logic. So undecidable but recursively enumerable. This one if you observe within k steps decidable. This is also within k steps decidable. This is, right, language of Tm less than or equal to 2. language of TM less than or equal to 2. Less than or equal to, not greater than or equal to, less than or equal to. So one string accepted, second string also accepted, less than or equal to 2 they are saying. So I think that means more than 2 not accepted, so you have to take care all the things. You have to take care all the things. So undecidable but not even partially decidable. Next one, that within Q states, I think it is the decidable. Next one, TM accept at least 3 strings, minimum 3. So I think if you are lucky 3 will come, right? Remaining all at least 3, right? At least 3. If you are unlucky, while doing that you may get infinite loop. Undecidable, partially decidable, true. At least 3 states directly without entering inside machine, you can check directly. TM accepts recursive, of course TM accepts guarantee recursive. Given TM accepts, right? See this one, given TM, I think I maybe misunderstood this problem, I will read once again. Given TM accepts recursive, given TM accepts recursive, given TM accepts recursive, so they are not asking whether you construct, right? They are not asking whether you construct recursive or not. Given TM accepts recursive language or not. Given TM accepts recursive language or not. Suppose that I have a Turing machine, it is accepting A power n, B power n, C power n. I have a Turing machine, it is accepting A power n, B power n, C power n. Now given Turing machine accepts recursive, I think need not be. I am really sorry for this, I misunderstood the problem. So answer for this one is undecidable. Sorry for this. Given Turing machine accepts recursive, maybe, may not. Next one, I think similar, but it is everyone now. Given TM accepts REL, of course. Next one, given TM accepts non-empty language, empty language, undecidable problem C. Next one, TM accepts A star, right? You have to check all the things, so it is going to be undecidable. Next one, TM accepts finite language, you have to verify, so C. Only, so C. Some string, right? Some string, so undecidable but partially decidable. Some is saying accepting string W, right? I think membership problem, option B. Accepts epsilon, membership problem. Halting problem, B. HTM, right? A. Fine, perfect. I think these are the things. Please verify. 20 problems are there, approximately 20. Please check. It is a 1, it is a 2. Verify. Small doubt also, if you find out, please let me know. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, yeah, totally 18 problem. 18 problems are there. Some may be confusing you, right? Anyone having any doubt, this is my WhatsApp number, you can ping me. Sir, this is the thing which I have doubt. I will explain to you. At anywhere, if you don't convince, you can ask me. Because of the undecidability, some problems looks like you may not convince, right? So you can ask me, definitely I will help you. Could you explain 8th? Let's go 8th. Let's go 8th problem. See this one. He is asking that I have a Turing machine. I also misunderstood this problem. Maybe same misunderstanding going on to you also. What he is asking is, there is a Turing machine already. He is not asking can you construct or not. He is asking there is a Turing machine. Does the given Turing machine accepts recursive? L is equal to Tm, where Tm accepts recursive. Tm accepts recursive. Tm accepts recursive. Does the given Tm accepts recursive? So, given Tm may accept recursive, may not accept. You can construct, that is fine. You can accept, there is no problem at all. See, given Turing, for the, if the question is, I have a recursive language, can you construct a Turing machine? Then answer is yes. I have a recursive language, can you construct a Turing machine? That is fine. But what is the question here? There is a Turing machine, right? That Turing machine accepts recursive. Maybe, may not. See, it is something like this one. I have a one PDA already. PDA for A power and B power and available. Will it accept? That PDA will accept recursive? Something like, right? So regular language, maybe, may not. Given PDA may accept regular, may not accept regular. Given PDA may accept regular, may not accept. What is the question? If I ask you for the given regular, can you construct for the given regular, can you construct PDA? Yes. But the question is, PDA is already given, right? Does the given PDA accept regular? Maybe, may not. Srinivas, that is the reason. Tm accepts recursive, maybe, may not. Tm accepts regular. Given Tm accepts regular, maybe, may not. If anyone asks you, can you construct? Yes. Can you construct? Yes. Thank you Srinivas, thank you so much. Yeah, you could have written, see, I could have written problem clearly, I could have written, right, I may be written shortcut, that may be the reason, some confusion. I could have written properly. I think problem writing having problem. That is the reason I also misunderstood initially. So if the question is, supposing that if the question is, right, can you construct a Turing machine for recursive? Yes. Suppose if the question is Tm already there, does the given Tm accept recursive? Maybe, may not. Given Tm accepts recursive, maybe, may not. Can you construct a Tm for recursive? Yes. So this is the, I think they could have written the problem little more clearly, right? Little more clearly they could have written. I hope you got it. Those people, if anyone having any doubt, they can ping me at any time. Thank you so much, right? So the purpose of today's class is this offer. Please use this offer. 53% offer is going on. 53%. If you take subscription now, if you take subscription now, 53%, right, offer is going on. Just take now. 53% offer is going on. So I am repeating that problem again. See this one. Given Tm, see the question now. Given Tm accepts regular, Given Tm accepts regular, no one knows. Given Tm accepts regular, no one knows. Undecidable. Undecidable. This is undecidable. Given Tm accepts regular, in the place of regular, you can write recursive. In the case of regular, you can write CFL, anything. Given Tm accepts regular, undecidable. If the question is, right, can you construct Tm, can you construct a Turing machine for regular? Tm for regular, can you create? Yes. This is decidable. This is decidable. Can you create Tm for regular? Decidable. Given Tm accepts regular, undecidable. That's the answer. Right? So 53% offer going on. I think you can utilize. Use the code ReddySir. You will get the 53% discount. Thank you so much. See you in the next class.